It's honestly wild to think about how fast AI has evolved. I mean, it feels like just yesterday we were playing around with chatbots that could, maybe help with our homework. But today, the stuff these systems are doing, it's straight out of science fiction.
So, here we are in 2026, and the AI we use every day is no longer just a passive assistant waiting around for us to type in a command. Nope. Our whole relationship with this tech has been flipped on its head.
Because now, it's an agent. It's a system that doesn't just give you answers, it gets things done. So what does that actually mean?
Okay, so let's get into what makes an AI agentic. Imagine telling an AI, hey, plan a full marketing campaign for our new product. An agent doesn't just give you ideas. It actually autonomously breaks that huge goal down into smaller steps. It can use tools like browsing the web for research or plugging into a database. It remembers what you talked about last week for context. And maybe the craziest part, it checks its own work, finds mistakes, and then fixes them. See? It's a total shift from a tool you command to a teammate you can actually delegate to.
So you got to ask, right? How on earth did we get here? How did we make this massive leap from those basic chatbots to these sophisticated, autonomous systems in what feels like the blink of an eye? Well, that is the incredible story we are going to unpack right now.
So here's our roadmap. We're going to trace the whole journey through 6 key stages. We'll start with the foundation, hit the revolutions in architecture and scale, dive into the reasoning breakthrough, and land right here, in the age of autonomy, and then peek at what's next.
First up, let's jump in the time machine and rewind the clock way back to the very beginning, the before times of conversational AI.
For decades, progress was kind of slow but steady. All the way back in 1966, we got Eliza, the world's first ever chatbot. Then, more than 30 years later, in 97, we got a new kind of model called an LSTM, which basically gave these systems a better memory. But these were all small steps leading up to the absolute game changer in 2017, the invention of the transformer.
So here's the crazy thing about Eliza. It didn't actually understand a single word you were saying. It was really just a clever parlor trick. It worked on simple pattern matching. If you said, "I feel sad," it had a rule that said respond with, "Why do you feel sad?" It was a neat simulation, but it wasn't a real conversation. And this whole approach was super brittle, totally impossible to scale up for the messy reality of human language.
And that brings us to the big bang for modern AI. A single moment that changed, well, pretty much everything.
It all kicked off with this paper from Google in 2017. The title? Attention is all you need. And honestly, it wasn't just a catchy name. It introduced a totally new architecture that would become the blueprint for literally every major AI that came after it.
And here it is, the transformer. Its superpower was something called an attention mechanism. Before the transformer, models had to read text one word at a time, in order. It was slow, and they'd often forget the beginning of a sentence by the time they got to the end. The transformer could look at all the words in a sentence at the exact same time and figure out how each word related to every other word. Think of it like being able to skim a whole page at once instead of reading it word by word. This ability to process in parallel was the key that unlocked unbelievable speed and scale.
And the impact was instant. Within just a year, this one single idea led to 2 totally different but equally powerful models. You had OpenAI's GPT-1, which read text left to right, perfect for predicting the next word, which is what you need for generating text. But then you had Google's BERT, which was bidirectional. It looked forward and backward at the same time, which gave it a much deeper understanding of context. Amazing for things like search.
So once they had this revolutionary new architecture, the game totally changed. The new philosophy was simple: go big or go home. Welcome to the great scaling race.
And the pace was just insane. In June 2018, GPT-1 came out with 117 million parameters. Sounds like a lot, right? Well, less than a year later, GPT-2 jumped to 1.5 billion. And then, just 15 months after that, GPT-3 landed with a mind-blowing 175 billion parameters.
Just let that sink in for a second. 175 billion. That's 1,000 times bigger in just over a year. And as these models got massively bigger, researchers stumbled onto something incredible, what they call emergent abilities. These were skills, like doing math or writing code, that the models were never explicitly taught, but that just sort of appeared once they reached a certain size.
And of course, all this scaling led to a moment that pretty much everyone remembers,
When ChatGPT dropped in late 2022, it put the power of these giant models into all of our hands. It became the fastest-growing app in history, and it proved that scale wasn't just some academic theory, it was a real-world game-changer. But you can't just keep getting bigger forever, right? The next great leap forward wasn't about getting bigger, it was about getting smarter. This was the beginning of the reasoning revolution. See, at their heart, these models are really just incredibly fancy next-word predictors. But then, researchers discovered a new technique called chain of thought. Instead of just asking for an answer, you'd ask the model to first think out loud by writing out its step-by-step logic. It seems simple, but this one trick dramatically improved how well they could solve complex problems, especially in things like logic and math. And that was the shift. The models started to actually think before they spoke. They'd lay out their reasoning, sometimes they'd even catch their own mistakes, and then they'd give you a much better final answer. It was a huge move from just spitting out plausible text to actually doing problem solving.
And you know what happens when there's a big breakthrough? A new race kicks off. OpenAI put out its powerful but pretty expensive O1 reasoning model. But then, just a few months later, a company called DeepSeek dropped R1. It was an open-source model that used some really clever tricks to get similar results for a tiny fraction of the cost. It proved that cutting-edge reasoning didn't have to be locked up behind a massive paywall.
Which brings us right back to today, the age of autonomy. This is where all those previous breakthroughs, the transformer architecture, the massive scale, and that new methodical reasoning all finally come together. So how do you actually build a modern agent? Well, you can think of it like stacking different layers. You start with a powerful reasoning model as the brain. Then you add a planning layer on top to break down big goals. You use frameworks to orchestrate the whole process. And then the critical part, you give it tools, the ability to browse the web, run some code, access a database. That's what turns a language model from just an answer machine into an action machine.
Okay, so let's zoom out one last time and put this whole incredible journey into perspective.
This table really sums it all up beautifully. We started in that foundational era with hand-coded rules. Then we jumped to transfer learning with models like BERT that could truly understand context. The scaling era gave us the raw power of GPT-3, which then led to democratization as open-source models caught up. The recent reasoning era taught these models how to think, and all of that paved the way for today, the era of autonomy, where these agentic systems can finally take action in the world.
It's such a profound shift in how we think about technology, isn't it? We're moving beyond AI as just a tool you command, and we're entering an era where it's a teammate you delegate to. So I guess the final question isn't just about what AI can do anymore. It's, with these incredible new collaborators by our side, what are the next great problems that we're all going to solve together?